Sup guys, the name's Mindalano, Amorphous Mindalano, and in this video you will be learning about the different types of structures formed by solid. But before that, let's have a quick recap about what solid is. So without further ado, let's start the video.
Basically, as we all know, solid is one of the three main states of matter, along with liquid and gas. On the other hand, matter is the stuff of the universe, the atoms, molecules, and ions that make up all physical substances. In a solid, these particles are packed closely together and are not free to move about within the substance. Therefore, solids have a fixed shape that is difficult to change, unlike the other states of matter. And now, let's move on the structures of solid. So there are two main types, the crystalline solid or simply crystal, and the amorphous solid. Crystalline solids or simply crystals are regarded as true solids. They are generally incompressible and have a very well-ordered shape or structure, and because of that, they have a very sharp melting point. There are four types of crystalline solid: ionic crystalline solid, molecular crystalline solid, network covalent crystalline solid, and metallic crystalline solid. Ionic crystalline solid. This type of crystal consists of ions that are held together by an electrostatic forces. These electrostatic forces are forces between positively charged ions and negatively charged ions of different atoms. Basically, when an alkali metal or an alkaline earth metal reacts with a halogen, this will always produce or mostly produce ionic crystals. Examples are sodium chloride, lithium chloride, and calcium dichloride. Another type of crystalline solid is the molecular crystalline solid. These crystals consist of molecules held together by an intermolecular forces called van der Waals forces. An example of this is ice. In the process of freezing water, we take energy away from it and it forms into ice. This happens because the water molecules form a very structured formation, and this creates what we call ice. Nonetheless, ice are considered molecular crystal or molecular crystalline solid. The third type of crystalline solid is the network covalent crystalline solid. This consists of a network of atoms held together by a covalent bonds. These covalent bonds can be both nonpolar and polar covalent. There are no individual molecules in the network covalent crystalline solid. The atoms are covalently bonded in a continuous network, and since each atom is covalently bonded to all the surrounding atoms, this results in having a huge crystals. An example of these are diamonds, amethyst, and rubies. The last type of crystalline solid is the metallic crystalline solid. This type of crystals consists of metal ions held together by a sea of electrons, and any type of alkali metal or alkaline earth metal are considered metallic crystalline solid. However, if they have a metallic-like structure, they are also considered as metallic crystalline solid. For instance, copper metal is a transition metal, but since it has a metallic solid structure, it is considered as a metallic crystalline solid. Other examples are sodium metal, potassium metal, lithium metal, and calcium metal. Any of these have a metallic-like structure, so they are considered as metallic crystalline solid.
Let's move on amorphous solids. Amorphous solids are literally solids without form and does not have a definite melting point. Instead, it melts gradually over a range of temperatures. Think of this as a candle wax slowly melting. Examples are glass, rubber, and most plastics.
Since we have learned about the structures of solids, let's try to differentiate them.
Crystals have an orderly arrangement of their constituent particles. In comparison, amorphous solids have no such arrangement. Crystals have a specific geometric shape with definite edges, while amorphous solids have no geometry in their shapes.